class period? Maybe 2 weeks? Yeah. It's okay. Better than some of you guys. Alright, we're going to do a one proportion Z test. So this is just, again, I'm not doing a specific problem, I'm just going through, like, in general, how you do it. So, first thing we would say is P equals the true proportion of blah, 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 and you're putting the context. True proportion of students that have a job, true proportion of people that plan to vote, true proportion of whatever. And then you're going to have an HO, which, what's that called?
Null.
Null hypothesis. Should we write that on here, or is that part of it?
Yes.
So, and it'll always be P equals something. That is your null hypothesis. It has to be equal. The initial claim has to be this is this. HA is your alternative, and that could be kind of weird to write this, but it could be less than, it could be greater than, or it could be straight up just not equal. This is still like section 2, yeah. So this is your alternative hypothesis. And then up here we'll also list what alpha is. So alpha will be given to you. That's your significance level. And then a lot of people like to put their p hat up here too. So you'll have like a fraction, like some, 40 out of 70 or something, and then you can make that into a decimal and you can find your p hats. Alright. Shape center spread. Same as done for a while. Shape is approximately normal as long as, so it's, you could say at least 10 successes, at least 10 failures, or you could say NP is greater than or equal to 10, and Q is greater than or equal to 10.
Which one is the AP test one you right here?
Either. They wouldn't be. That would be like if I said what's 2 plus 3 and there were 2 answers that said 5. Like the same, they're literally the same thing. Center. So your center is P. As long as what? Randomness. Well, yeah, so it should be stated. Or if it's not, you just kind of, like, we assume it's random. So you can, like, continue with the problem. But if it's a multiple choice and it's not stated, then they're definitely doing that so you notice it's not stated. If it's a free response, I would think it ought to be random. But if it doesn't say random on a free response, you should just put assume random and complete the process. And then the spread, so our standard deviation is the square root of PQ over N as long as N is less than 10% of the population. So if you're labeling, that's like your intro, or some people said state. This is conditions, or what did she call it? Plan, I think she called it. Then it's a math box. So then you're going to say Z equals, we're going to do it in words, and then symbols, and then in numbers. So it's the statistic. Statistic comes from what? Sample or population? Sample, good. Minus parameter. population divided by standard deviation. So how do I notate statistic if I'm doing one proportion? So the statistic is just p hat. That's what I was looking for there to start. And then the param, so that's like your sample. That's this thing that we did up here when you found it. P is the claim that they're making that is true about, that they think is true. They're claiming is true about the population. And then your standard deviation is root PQ over M. And then you'll plug in your numbers. I'm going to indicate that with like little dotted circles. And you will get a z-score. So there's three ways it could happen. It could be because the z-score and what you do after that is different depending on whether this is less than, greater than, or not equal to. So I'm going to kind of try to separate each of those. So if it's less than, if HA was P is less than whatever, then you'll have a z-score that is negative. And to find the p-value, normal CDF. If I want to find this area over here, that'd be negative 999 up to whatever the z-score is. Like shaded in this part. If it is greater than, if HA was P is greater than, everything just flips. Now you're looking up there. P-value would be normal CDF from Z to 999 now. And then it could also be that HA was P is not equal to. And so if that happens, you may get a positive z-score or a negative z-score. It could very easily go either way. But whatever you get, you got to do the other one too. So if I got like a positive 2 for my z-score, I'd go to z equals 2 and shade above it. I would also go to z equals negative 2 and shade below it. We're looking like either side. And then your p-value, basically you could do either of the two things we did up here. So you can find that section or that section, and then what you do with it. And you double it. So I'm going to say like double that or that. Or like I was pointing out yesterday, you could do normal CDF 1 minus normal CDF negative Z to Z. Seems a little like more complex than it has to be, but that's good. If it works for you, it works for you. And then we get those two possible conclusions. I don't know if I have enough room here. I might be squeezing. So we got to look at what happens if p-value is less than alpha and what happens if the p-value is greater than alpha. So if, let's just do both. So since p-value is less than alpha, so that's one of the possibilities, right? Just in case you're wondering, I've never seen them make it equal. If they came out the same, I'd be like, okay, which one am I supposed to do? And they're not going to do that. They're going to make it clear it's either bigger or smaller. So if the p-value is less than alpha, what do we do with H naught? With null? If it's less. The p-value is the probability that what you saw occurred randomly, due to random chance. So if there's a very, very small chance that it was due to random variation, then we're rejecting H naught. It's more likely that the claim was just wrong. So we reject H naught. The test is statistically significant. So again, we're making statements here. I'm going to make a statement about HO. I did that. I rejected it. I'm going to make a statement about whether it's statistically significant or not. So whenever we reject, it is statistically significant. And then I'm going to make a statement about HA. Well, if I rejected HO, what are my thoughts on HA? So I never reject or don't. If I rejected HO, I'm doing it because I think HA is better, right? That's what I'm trying to get to. So we suspect HA is true. We didn't prove it. We're just like pretty sure. And again, some people might. You could easily at this point be like, "Hey, wait, we're supposed to have context in there. Like you didn't write any context." But I actually did because I referred back to HO and HA. Those are defined up here. And those have a P in it, which is defined up here. So I'm like, reference. That's kind of why I set it up this way. So you can just reference earlier things without continually repeating the context. All right, so the other possibility, or since P value is greater than alpha, we fail to reject HO. Remember, we're not accepting it. I just can't call you a liar. I didn't confirm what you said, but at least you're close enough that I can't call BS on it. So then the test is not statistically significant. That's hard to say.
That's what I do. I just write stats.
Yeah, I get that, but like on the notes, I should probably write the real words. The writing was fine. Statistically significant. And then, if I'm not rejecting HO, so I got a choice basically. If I'm not rejecting HO, then what does that tell me I think about HA? Good or bad? Bad. I'm not rejecting HO. So I can't accept it, but I think HO is probably pretty reasonable. Which means I don't like HA. So we suspect HA is not true. Man, that is a solid template. That is some kick-ass work there. I got it.
Mine looks like page 2. That's like.
Pretty, yeah. Questions on it at all, anyway? Guess we'll find out. I'm gonna have you do one, like using that, and then I'll give you the rest of the time for your con. So let's say, I think we've done this before, but raise your hand if you prefer the 6 block day to the 7 block day. Yeah, it was over 3 years. Oh, I think it's different. This has changed. That's only one person.
Well, no, I guess not like.
How many people prefer the 7 to the 6? Because you might just not care.
No, like.
We didn't have everybody raise their hand.
How many just don't, like, it's fine either way, you don't really care? Okay. So let's do, the school board, they made the decision, right? They wanted to look good. Claims 75% of students prefer 6 hours. And SRS of 40 students results in 75% would be 30 out of 40. Let's say it's 26 out of 40. 26 people that prefer. Then the question would say something like perform a significance test to see if the actual proportion is different from 0.75. So is that a one-sided with the less than or the greater than, or is it a two-sided with the not equal? That's a two-sided because I'm just saying see if it's different. I'll give you some time to work on that. I'll write it up. Oh, good. Alpha equals 0.01. Get your calculators out too. I guess you probably already have. You only have one proportion, right? You have 26 out of 40. That's your one proportion. If it was two, it'd be like 26 out of 40, and then this other group was 30 out of 40 or something. You'd have to have two. Yeah. I'm going to call them 6-hour truthers. You're a 7-hour truther? You like 7 better? What? Is that why you like it?
I mean, a factor. Yes.
That's crazy.
For some reason, my illustrator counts the math and science.
can check with mine up there. I'll talk through a little bit after. If you have questions in the meantime, let me know. Random what? That'll be cool. Zero. So the reason we would put the mean and standard deviation there is if we didn't know the z-score, so the calculator could figure out the z-score, but we do know the z-score. Be pretty careful checking it because I think it's easy to look at like, oh, I got that number and that number, so I'm good. But just remember, you got to show, HA and HA have to be there. You got your alpha. This doesn't have to be there. This is kind of like to help you because you end up doing it down here again anyways. Make sure you got your conditions, showing your formula in words, in symbols, in numbers, and conclusion. So just check it like diligently. Questions I can answer on anything up there? Alright. So go to your calculator. Your calculator actually does this. And go to stat tests. Like the same menu where we did the confidence interval. I think still right. You want me to wait or you can? I can put it back. So, which one is it? What are we doing? One prop Z test, number 5. So PO is like, what is your H, what is the P for H naught? So that's the like claim. PO is your claim. So that's stat, tests, and then number 5 is one prop Z test. So PO is their initial claim, and then you put the fraction like from your sample. So it's 26 out of 40. And if we go to calculate, we'll draw it in a second too, because that's kind of cool. If you go to calculate, like that's the numbers we got, right? So it gives you a z-score, it gives you the p-value. I want you to realize this. We found the p-value by finding like one of the tails and then doubling it, right? Because there were two sides. If you do the test on the calculator, notice that that's already doubled. Like they know it's a not equal to test, so they're adding on both sides already. So if you double that, you're in trouble. So you either do it like the way we do it by hand and then double it, or you can use the calculator and just look at it, but don't double that. It draws it too, which is pretty cool. So if I go stat, test, if I just go back, stat, tests, one prop Z test, and the drawing actually gives you all the I know what I'm supposed to do. It didn't work. Does it work for you guys?
Yeah.
Everyone else can draw except for me. And it tells you the p-value and the z-score, right? So like you got all the information you need there, which I got. Just reset my memory. There you go. got what you need. So just remember that this p-value is the total of these two. So it's like 0.72-ish in each of those. Don't double that, or you'd be having a p-value of 0.28. Questions on that process anywhere? Anywhere? Like the template or the one we did? Alright. Yeah, rest of the time to work on your con, how to get started. Oh, there's one I want to show you. There's one con I want to talk about. It was like the p-value section, right? Oh, the first one I assigned this time around. I think it's this one. Estimated. Okay. Okay. This con, I'm going to get a million questions on this section. So, like, from my perspective, I'm just trying to answer them all at once instead of 30 separate times. This is a tricky section, and we don't really talk about it this way, but it's good. It's good to look at it this way. So this one is saying the mean is 17. We want to test this theory. So the mean is 17. And we're looking at an alternative hypothesis of less than. And then our sample result in this case, can you guys see this? Like in the back, is it big enough? No? I can. So, their initial claim is mu equals 17, which is right there. And the alternative hypothesis is mu is less than 17. So our sample result comes out to 16.5. 16.5 is right there. The p-value is like when we shade the p-value on a less than test, wouldn't I do this and like shade this part? Is a less than test, I'd be looking at that tail. On a normal distribution, the whole thing adds up to 1. We have normal CDF, and we can find like exactly the proportion in a real normal curve. This is like a simulation they did. So looking at their data, and to find the p-value here, you look at it's still there, like the percentage. So how many dots are at 16.5 or less? 5. How many dots are there total? 40. So 0.125. So that'd be your p-value. So you're counting the dot if it's not equal to what's equidistant from the middle on the other side. 17.5. And then now how many dots would you have total? 8. 3 plus 5 is 8, then you would do 8 divided by 4. That makes no sense. I mean, still try it. If you have questions, let me know. I'm just trying to like, give you the intro to it. But yeah, go ahead and get working on your con. At me if I can help.